Hey, how's it going, guys? Daniel here, aka HashLips, and first of all, welcome to the very last video of this series. It's very cool, and as it has been a journey creating this particular tutorial, there was just so many concepts that I wanted to get through that I didn't have the time to do. But that being said, there is a lot of time for us to spend together where I get to teach you guys little bits and pieces here and there. The tutorials that will follow this tutorial will be a lot shorter and much more concise. The reason why I wanted to make this is to actually show you guys everything involved and how you can come from creating a smart contract to actually having some sort of a game and some sort of way that you actually achieved creating a smart contract and interacting with it on the front end. So just want to say also thank you guys for listening to me, blabbering along, making mistakes, fixing it with me. And I hope you guys really enjoyed this tutorial. I really want to take this on and make it a passion to teach code. So if you guys really enjoyed this video, please leave your last comments on this video for me as well. Share it with your friends and subscribe. And I'm very excited to show you guys a lot more in the future regarding code. I know my brain is sometimes all over the place and I love just to talk, but I think let's get down to this last episode where I get to show you guys what we're going to be doing. So let's get to it. You will see that I've added for the to this project, I've added a few folders and files. Firstly, let's observe this assets folder that I've added with images in it. The first folder is a background, which is simply a color background that we'll use to beautify our work. Next, we have got this parts folder, and these are different bits and pieces of images. Now, if you haven't seen my previous tutorial where I actually show how to create some random images and a randomized NFT, this kind of touches that. It's not completely the same, but it is indeed a bunch of separate images that we are going to be concatenating together. Don't worry about the naming structures of these yet. I'll explain them as well as we go along. But just know that in these folders, each folder contains 5 images, and I'll show you how we're going to be using them. Then next we have a rarity. So these rarity PNGs are also square-like, and it ranges from original rare and super rare. We have this wrapper, which is kind of the back wrappers that we can choose from. I'll also maybe show you guys something exciting with the wrappers. So that will be like a little bonus that we can add to this tutorial. Then what I've added was an extra folder. So if we close the assets, we have a components folder. In the components, I've added a lip renderer .js component. We'll go through this step by step, but basically we'll be using this to render our lips. And then what I've also added was this parts folder which contains a parts.js. This is kind of an ugly file, but basically what it does is it imports the images that we've seen in the images file in the parts. It imports them, each one of those images, and then just nicely exports them into the respective names. So I said that these names don't make sense, but if you look at it like this, you can see that it goes towards background, M for mask, L for line, A for add-on, and then AM2, AM1, AM3 for add-on mouth 1, 2, and 3. And that's what we have. Okay, so that's what we're going to be working with, and I'll show you how we're gonna make this all work. Okay, so firstly, what we would like to do is actually have some way of rendering our NFTs. Currently, what we have is this kind of structure where the NFTs get rendered, but they all get rendered in text, and it doesn't look really nice. We can't see any NFTs, but I told you there's a way that we can take this DNA string and actually create something of it. So how are we going to do this? Think about it like this. If we have DNA, DNA is built up of some kind of mechanism that kind of can every time spit out the same image. So how will we do this with our DNA? Well, what we'll do is we'll take this DNA string, the whole one, and then we'll split it into 2 digits each. And these 2 digits will then kind of tell us which image to use. And then we're going to use overlapping images to build up our lip. So we're going to start with a background, then a foreground, then a mask, and then so on and on and on. It's better if I show you. So let's get into the code and let's go and fix up our app.js that we've touched. So if we go down to where we actually render the lip, there's something that we can do right off the bat. And let's go and have a look at our components folder and then the lip renderer component that I've imported. If we look at the lip renderer, we can see that it references parts, which is that file that contains all the references to all the parts. We also have a few properties such as the lip that we need to pass. We have a size that sets a size and a style for in case we have styles that we need to apply. Next, what we do is we extract the DNA from the lip, turning it into a string. We then go and loop through it and we check as long as the lip.length is less than 16, we pad it with zeros. Then what we do is I create this object called lip details. And here it's very interesting. I create this lip details and give it a background. And this is where we talked about splitting those DNA strings into 2 2s, right? So we take the DNA string and we call the substring function, which actually splits off a section of that text. So what we do is we take from 0 to 2, so the first 2 digits, and we then modulus it with 20. Now in our case, this won't work because if we look at our images, we only have up to 5 images in each kind of layer, you can call it, because here we do the background, the mask, the line, and all these. So we want to actually modulus this by 5. So we know that we will actually be getting a number that gives us back from, I think it's 1 to 5, right? Or 0 to 5. But regardless of that fact, every time we do that for a new layer, we increase the substring. So now it goes from 2 to 4, 4 to 6, 6 to 8, 8 to 10, and you get the picture. It goes up to 14, so we're missing 1, but that's fine. And then we're also extracting the name into this lip details. Next, we actually go and add a little bit of a lip style, which is just 100% width and height and a position absolute. This is really important because we want to overlap the images. Then we get a div, which we also apply the style. This style actually comes from props if there is one, otherwise it's 200. Then we turn the background blue so we can see what we're doing, and this div is position relative. Okay, so now what we do then is we actually apply each layer as an image. We start off with the background image, and then we say, well, the parts.background, and then in the array, we give it the actual value that the lip details, this object, selected. So this might be 3, this one might be 4, this one might be 5, this might be 1. You get the picture. So it basically selects one out of the array. And we can easily do that because if we look at the parts.js, we see that these are arrays, and it will simply select one out of this array for each one of the layers. So that's what it does for each and every layer. And let's go and see the results. So if I go into my app.js and I go and import the lip renderer, so we're going to say lip renderer. So there's the lip renderer, and we can actually now put it here. So I don't want to put this there, so I'm just going to comment this out for now. I'm going to put in the lip renderer, and for the lip, I'm going to give it the item that we've rendered, meaning that we actually give it the item, and it hopefully it doesn't break, and it doesn't. and it's pretty cool. And you can see actually off the bat, these are all different NFTs. One has a purple background with yellow lips and so on and so on. So the more variations you have, the more you can experiment with these and the better they will then eventually look, right? So there we go, and we have them right there. So we can do this a bit better. So what we can do is that once we render this lip, because we actually want to also be able to read some of the stuff, okay? So I'm going to make it so that let's have a container, okay, that wraps everything. We're going to put that lip renderer in there, and we're going to put the ending container there. So let's just see how that looks. So perfect. So now we've got a lip with all of its details, and that's pretty cool. And we'll always get this to render because the DNA will never change. Now, in order for us to actually gamify this in some way, there's many different things that you can do. But before we get to that, let's just add some spacing quickly and just roughly do a bit of cleanup, just so it looks a bit better. So I've noticed this space below the lip can probably be medium. Then we can also add a space between the lip and this actual container. So I want to add a medium space over there. Okay, and maybe not medium, but maybe like an extra small space. This will just give it a bit of breathing room so we can see that everything looks and fits nicely. Next, what I want to do is right inside app.js, I want to say import. Let's import the color from the new assets that we've imported. So we have assets, images, and background, and then we have in background, we have the color PNG. So there we go. And what we can do is for the screen global style that I've created, if we look at our global styles, for the screen one in particularly, I added a prop that it can take as a background image. So it's fairly easy to add our background image here. All we need to say is say image and then equal it to an image basically. And then you can see our background changes to this beautiful color, well, to the beautiful image, I would say. All right, and I'm happy with that. But we need to see what happens when it squeezes. Maybe we want to align these things a bit better. Now, I'm not here to do a lot of styling because that we can definitely keep for another video, but it doesn't hurt us to just try and style it a bit better, right? So this is row, and I know we said justify content space between, but we might as well try center here, because the thing is, it will wrap, but it will also then expand, and it will keep things nice and centered. What we can do though is maybe add, instead of a padding or a space, we can maybe add a margin or a padding around these things. And I think that's what we should do. So instead of adding a small space there, I think we should rather add a style in there, like so. And let's say maybe a padding of 15 pixels. Okay, and there we go. And now what we have is something that's nice and scalable, and also we've got a bunch of lip-tilt rendering. Perfect. The next thing that we can do, and this is just something for me to show you guys, is let's go and adapt how much it costs to actually render a lip, and let's reset our smart contract. Let's go and redeploy it because at the moment it's a bit expensive. So let's head up to the contract section. Let's just close all these files a bit. Let's click on lip token, and let's go and say, well, we will be fine if we can render a half ETH, right? Half ether. Perfect. Previously, I told you that there's a better way of using Web3 utils, which we're going to be using now. So let's just define a price. I think 0.01 Ether is fine, because the thing is we don't want to make it too expensive, right? The fee right off the bat. So I think that's fine. What we can do is we can save it, and down here we can say truffle migrate reset, and that will reset the contracts for us. We do need to change where we mint the NFT on the front end, because we need to adapt it to this. Now we can say yarn start again to start up our web server. And if we go to the application, we will need to update where we send away. So there it is, add the value. Now what's nice is Web3 actually has utils two-way, and it can specify what we want to do. So we can actually say that we want the way value of 0.01 Ether. Okay, and this will actually put the right value in there, and that's very important. We can't access Web3 just like that, but remember we had a Web3 instance in our blockchain. So if we say blockchain like that, it will be perfectly fine. If we go back to the app, you'll see if we connect now, there's no NFTs. And the reason for that is because we just released a new instance of the contract on the blockchain, meaning that it cleans out the state. So that's why I say every time there's a new contract on the blockchain, it's a new contract, right? And that's why it's very important to make sure your code is perfect before you deploy it, because once you've deployed that contract instance, that's it. You cannot change it, right? So that's why we have to, if we make a change, we have to redeploy the contract, meaning that there will be no lips in the beginning. But let's go and create one and see if this updates correctly. And indeed it does. Here we get 0.01 Ether, and we can say confirm, and boom, it's there, right? We've minted an NFT. We can mint another one, and we can mint another one, and they come out differently. Obviously, like I said, the more different varieties you have, the better it will be. So I think just play around with varieties, and you can do a lot. You can do a lot with this. So this is actually minting on the blockchain. So this is on the blockchain. This is really happening there, and looking good so far. All right, what can we do next? Let's think about this. So we can also kind of gamify this in a way where we want to render the rarity of the NFT, and we don't really have a way of doing that. But maybe, just maybe, what we can do is we can adapt this render lip function, or this render lip component, to actually show a rarity on there. Now, how can we do that? Maybe we can just have a look at what we have. So let's see, images, we've got the rarity, we got the rarities there. So let's go ahead and import them. Okay, so we want maybe, let's call it R1. Okay, so let's call it R1 from. So it's going to be two back, assets, images, rarity, and rarity1.png, like so. Perfect. We have three rarities, so we're going to duplicate this 3 times. We're going to change that to 2 and 3, and same here. So now we have these in there, and I think what we can do is maybe, okay, let's think about this. Maybe what we can do is, after this lip check, we can have a new variable. So let's say rarity. So we're going to say rarity, and we're going to assign rarity to maybe 1. So we're going to assign this to this right from the start. So we can actually pretty much just duplicate this and place this there and call this rarity for the browser. But then in the source, we actually call it just the rarity, and then this will have a lip style. I just want to see what happens when we render this, and there you can see there's that little original that we have selected. But I want this to actually change, so we can do a basic calculation here and maybe check if this is that, if this is this. But what we do know is that the lip also has a rarity on it. So if we go and look at it, we can see that the rarity is there, but it's not being displayed properly. And why is that? Because everything else comes back fine apart from that rarity. If we look in the console.logs, if there's maybe an example that we can see, we do have the rarity. So let's go back to our app.js where we are rendering the lips and see. Okay, perfect. I've spelled it wrong. That's why it's not there. Okay, cool. So now what we want to do is, if we go into the lip renderer, very simple. We can do case statements, all these kind of things, but let's do if statements. So we can do if, and we can say if the lip dot rarity is greater or equal to, so let's say if the lip rarity is greater or equal to 80. Okay, so meaning that 20% of NFTs will be rare. Okay, that's it. And then if it's greater or equal to maybe 5%, but okay, if it's greater or equal to 5%, then maybe it's a super rare. But just for the case of this video, let's just change it if it's greater or equal than 20, and if this is greater or equal than 60. So we can just see that we do get different, and we need to take out the assignment here, okay? Just to see if it works. Okay, so, and yes, indeed it works. There we can see we have super rares, originals, super rares, super rares, super rares, originals. Now this works, but we now definitely need to up the value. So maybe we can say 20% is rare and only 5% is super rare. Okay, but we're doing this wrong because this needs to be greater or equal to and greater or equal to. Okay, greater or equal to, greater or equal to. Perfect. That is the rarity that's been added to our no, but this doesn't work. So let's just see. A warning, each child should list the key prop. Okay, fine, we'll get to that now, but we don't know why this doesn't work. Okay, okay, wait, no, that is correct. If rarity is greater than 5, okay, that makes sense. Sorry guys, I wasn't thinking. This should be 95. Then obviously that will be a 5%. Alright, perfect. So everything should be original. And we have actually one rare because it's 89 rarities. So let's create one more. Maybe we're lucky. And this is, oh, it is a rare. So this is kind of forming part of the game, right? And one last thing that we can do, just to have some fun, we're quickly just going to fix this error up here, which says that the child needs to have a key. Basically what that comes down to, if you look at where we are rendering them, you can see there's a container. All you basically need to do is just say key, and then in the key, we can also have the index being returned. And if you put that there, then it should be fine. There shouldn't be any issues with that. Perfect. The last thing, like I said, what we can do is we can actually go back to our contract or smart contract, and let's do a small function just to show some kind of interaction and some kind of thing that you can do, and then you can expand on this idea and you can basically make anything possible. All right, so let's go into our getters, maybe helpers. No, let's call this section actions. Okay, actions, and we're going to have a function. So our function is going to be called level up, and it's going to be level up. Now what we want to do is think about this carefully. So we want this to be public, and let's just end it like this for now. Let's just call it level up. One thing that we do actually need is some kind of modifier to see if this is our lip, right? So we're going to need a uint to 56, and we're going to call it lip ID. So we've got this lip ID. Now remember, we have this owner of this one, right? Now we actually need to do a check. So how you can do this is you can say require, and our check is going to be if the owner so we're going to say if owner of lip ID is equal to the message dot sender. Okay, so what happens here is this needs to be, so the owner of this, meaning that this will return to us an address, this is an address, and these two need to be the same. Otherwise, this is not the person's lip, and he doesn't own it, meaning he doesn't have the rights to do whatever we're about to do right now. Okay, and it will cancel the transaction. But basically what we want to do now is we actually want to update one of the lips. Now I've only shown you memory this far, but now I'm going to show you how to use storage in a way. So you can actually say lip storage so is going to be equal to the lips, and then in the lips we need to go and grab the lip ID one. Okay, so let me just think about this. Okay, there we go. So the lip storage lips is equal to this lip. Okay, and now it means that we've grabbed this thing in storage. So if we now go immediately and say lip.level, okay, is plus plus, meaning that we've leveled up this lip. This will directly change the lip inside of this array. Because it's storage, it references to that. If it was memory, so for instance, if you said memory in here, and you said, well, this is the memory of this lip, this doesn't change anything in the blockchain, okay, which is not cool. So what you'll need to do then is you'll need to say, well, the lips underscore lip ID is equal to this lip dot level. Wait, actually you need to first do the lip dot level plus plus, and then you can assign this to the lip. That's how you do it in memory. But I mean, it doesn't make sense to do it in memory if you can do it with storage like this. It's just much more concise and much more cleaner. Okay, so let's do this, and actually let's just kick this off and make this a function that we can call in the front. Again, what we need to do is we need to redeploy the contract on the blockchain, so we can check our terminal blockchain over here. It's busy deploying. So here at the back you can see it is successful, so that's fine. Next we're going to restart our front end. Perfect. We're going to go back to app.js. We're going to go back to app.js, and in here we want to create a new function. So let's just actually duplicate this minting function that we had, because we can reuse it, right? Perfect. So what we need to do now is actually, this is now not going to be mint NFT, but level up. Okay, let's call it level up lip. But in our token.sol, we need to get the right thing, because we're going to have to call it. But let's look at the parameters first. We need the ID, okay, and then what we need is create random lip, and we don't want to call that function, we want to call level up, and then what this takes is the ID. We still need to pass that through. This is going to come from the accounts, but we don't need to send a value because it's not payable, and we're going to leave these two here because we want to dispatch the blockchain afterwards, and we want to log these out just to have a look at it. Perfect. What we're going to do then is we're going to copy the button and actually include the button inside where we render the lip. And the reason for that is because we need to know the ID of the lip, which we're getting here. Okay, so if we go up to where we've initialized, well, where we've created this function, level up lip, we can now say, well, rather call level up lip, and level up lip needs to get the ID. And we have the ID because we have the item, right? We have the item dot ID there. So once we save it like this, we can say level up like so. And here it says account is not defined. So why is that? That is because we are passing the account there, which there's no need to. Well, we can probably add the account there as well. Okay, so let's do that. Let's add the account there as well. So we have visibility of the account, meaning that when we call it, we still need the blockchain.account. Okay, then that's fine. Then that won't give us an error. And when we connect, we can see when we create a lip, we pay for it. It's there. There's a level up button. Let's just do 2 maybe. And before we carry on, let me just put a little bit of a space there. Okay, so let's put a little bit of a smaller space there, just so we can see. Okay, there we go. And we've got our NFT here. We've got our NFT here. We want to level up this one. So let's click level up. Perfect. Let's do that. And you can see it's level 2. And you can see it's level 3. Let's level up this one. You can see that one's level 2 and that one's level 3. So now you get to this whole thing where you can start creating a game. The last thing that I actually want to just explain to you guys is that I mentioned this before, that the blockchain here mints and mines immediately, but you need to have loading states. Okay, so the way you will do that in like React, for instance, is you will create something like state. So you can actually say use state, and I'm just going to make a very mundane example here, but you can say const and then say loading. You can also say set loading. So we're going to make it equal to use state, and it's going to start off as false. All right, false. Now set loading, what you're going to do is you're going to say set loading on this mint NFT. What is going to happen here is you're going to say boom, on the start of this function, you're going to set loading to true. Okay. After that, if there has been an error that occurred, you're going to set this loading to false. Okay. Then that's going to happen exactly the same for recipient. Let's do this maybe for this function as well. Okay. So now let me do the exact same. So we're going to take the is loading. You can make separate loading states, which is a good idea, but I'm just going to do this to prove a point. Okay, and we want to set it to false there as well. Perfect. Now we got this loading state, this loading variable that will be in different states as the person calls blockchain functions. The person will call mint NFT and it will load. Then if it's something goes wrong, it will not load, as well as if it goes right. It means that for the time being that it loads, we can actually disable buttons. Okay, so especially, let's think about this. We actually want to say, well, there's no loading on the button, so we can actually just say disabled should be if loading is true. In React, you can actually do this if you're using booleans. You can query them like this so that it works correctly. Okay, but anyway, everywhere where we have a button, we need that. So I'm going to save that, and then also maybe we don't need it on a connect, so that's fine. But what I want you to notice is if I click there, check what happens. I click and these gray out. I cannot click on it again because we want the MetaMask we want this query to finish, right? So we can reject it and you can see it's available to click again. If I click even create NFT, it blocks out. If I say confirm, once the transaction is done, only then it is enabled again. Okay, so the last thing I want to just add to this whole thing to wrap this up is how to actually deploy this and run it on the Matic main chain. Now, this is going to be a video that you guys can do. Please keep in mind that deploying this contract of your own is not really secure. There's a lot more that you can do to secure it and work with it. So play around. Make sure all your functions are secure, everything is working correctly. But needless to say, what I'll do is actually deploy this and show you how to do it. The first thing that we just have to add is a way for the user to know that they are on the right network. And how do we do that? So if we go back to app.js, remember that we said that there is this connect button, and when you connect, this actually shows up, right? Well, we also need to show the user that there's an error state. So for instance, if you go back to our connect game, we connect, everything is fine. But what if it's not fine? What if the user's on the wrong network and all that stuff? Well, remember that we actually set up for success when we were adding our state. So when we were adding the Redux states over there in the blockchain, we made sure that we have these case statements and the if and else statements to make sure we print out the correct error messages. So what we need to do, and it's very simple, is maybe add an extra description title down here and say, this will be maybe the description and not the title, but it will come after the connect button, which we can add an extra spacer. I'm going to make it an extra small spacer. And then what we can do is we don't always have to show this, so we can hide it based upon logic. So our logic will be if the blockchain, and I think it's called error message, but let's just make sure. And there we go. So if the blockchain dot error message is not equal to empty, right? So if it's not empty, then obviously we want to display something. And the actual thing that we want to display is the error. We have to wrap it in there with curly braces, and then else we just want to display null. Oops, like that. And that will give the user a kind of understanding of what's happening to your contract. So they can go and connect perfectly fine, but let's say they weren't on the correct network, let's say they were on the Ethereum network, then they connect and it says change network to Polygon. This will also catch things if they don't have MetaMask and tell them about that too. But as soon as the user goes and switches to the correct network, which we have not as Polygon, right? We're on the test network for now, or our own blockchain. When they connect, they can actually see the lips. Okay, so actually deploying this contract, like I mentioned, we're going to do it through Remix. You can do it through Truffle by setting the configurations, but let's go ahead. So what you need to do is actually open up Remix, go and create your contract, or if you already have it there, just update it. What we can do is just set our version to be our version that we have worked with, just to make sure it compiles. And here we actually need to grab those Open Zeppelin copies. But let's go and check. Maybe the Solidity version actually incorporates them, because it says that it can compile. So it's probably getting this from the local, from its local folders. Let me just check. We'll see if it compiles just now. But anyway, what we want to do is, I think this is fine, the ethers. I think these tokens are fine. Everything looks good. And what this contract won't have is metadata. And the reason for that is because we don't have any metadata to give it, right? All our lib IDs and things sit on chain. So maybe in the next tutorial, I will explain how to do NFTs with metadata and make a whole art collection of it. But this is not an art collection, this is a game. So they're not going to have metadata here. But needless to say, let's go and deploy this. So once you've uploaded your contract, and just a side note, again, when you do this, don't go and deploy this contract that I've built up here. Make sure your contracts are very secure. Make sure that you double check and make the accessibility to these good and solid. All right. I'm not saying this is not solid. I'm just saying don't take my word for it being solid. I'm here to give you guys a tutorial. So let us go into deploy and run. Previously, we've selected the JavaScript VM, so the virtual machine. This time we're going to do, I think it is Web3. No, it's going to be the injected Web3. Now, what this means is this is actually looking at your MetaMask, and it's looking at what network you're on. So if you are on Ethereum, please be careful with this, because if you are on Ethereum, this will actually deploy on Ethereum. You need to be on the network that you really want to deploy. This is the Matic main network. So please set up the Matic main network correctly, and you'll see that the chain ID is 137. We also need to switch to an account that actually has actual Matic in it, because this will be a real transaction and not something that's just testing, right? But I want to show you guys this so you don't get stuck. Now next go to lib token and we select our contract. Here we're going to add something. So I'm actually going to say this is the tutorial lips. Maybe we call it the tutorial lips, and we'll call it T lips for the symbol. Okay. So now that we have tutorial lips and T lips, we make sure everything looks fine. We make sure the rarities are all there, and the functions. Let's see. So level up will level up. It will require that the lip is the owner. Get the owners of the lips. We have all these. We have create. We have our withdraw function, and I'm actually going to build this contract right now. So now we can click deploy. And what will happen now is this will actually pop up a real transaction. So make sure that you are happy with your contract. I'm going to click confirm, and this will actually now start minting and creating on the blockchain. And there we go. It is successful. I'm going to click on this just so we can actually see what's happened. But we can go back to Remix, and we can see there. Now, this token address that you have, well, the token, the contract that we have here is the one running on the Matic main network. So I'm going to prove this by copying the actual address and then going to polygon scan. In polygon scan, I'm going to paste the address in here and search for it. And there we go. There is the actual contract address that we've created, and we can verify that by looking at the, let me quickly check. This is the contract creation from this to this. Okay, and that should be fine. Now, this is the actual contract. So what we want to do now is connect this contract to the front end and actually work with it in the front and actually mint a real NFT on the real blockchain. So let's go back to our code, and there's now one thing that we need to actually change. So let's have a look at it. And what we can do is we can go to our Redux where we connect to the blockchain, and there's only a few things that we need to change here. So you see here where we get the network ID, this will most certainly print out 137. And what we can do is we can console let's console.log this out. So let's go to the game and actually inspect it. We're going to go to the console and we're going to connect. Okay, and there we see 137. So that is the right network that we are on, okay? but it still says switch to polygon because we need to do that change. So all we need to do here is in this if statement, we're going to say, well, the network ID needs to be equal to 137, which is the polygon network. We're not going to need this thing anymore because we already have the address. And the address, we're going to paste this. So we have the address of this. We have the token ABI because it hasn't changed, and we do have a copy of it. So that should be fine. And if we save this now, check what happens. If we go and we connect, we actually connected to the real Matic network because I am on Matic right now and it's using real Matic. If we switch to any other network, it will log us out, and if we connect, it would say change network to Polygon. So if we go and change it to the real network, Matic main network, it changes and we can click connect, and it does connect. And let's actually create a real NFT. So I'm going to create a real NFT. It's going to cost me some real Matic, and I'm going to say mint. Check what happens. This disables while we wait for this block to finish. So this will actually have to be mined now on the blockchain for it to go through. And this is the whole tutorial coming down to this point in space, I guess, where we hope this works perfectly and that we get an NFT to render now. So basically, once this is done, we can check it out. Oh, there it is. There's done. And this is the first NFT that's minted through this game that I've done on the tutorial. So this is pretty cool. I'm very excited about it, and I hope you guys are too. Now, if we look at the Polygon contract that this address is pointing to, right, you can see that 37 seconds ago, there was a transaction from this account to this account. And how nice is that? We have minted our NFT, and there's the value that passed through. I paid that Matic. It's in the contract now, and also there is there's the transaction. So our app is actually live on the network. Please don't go and buy these NFTs on this contract address after seeing this tutorial. I'm not gonna work on that contract at all. This is just for tutorial purposes on the real blockchain, because I feel people need to actually expose how to do this, and I hope this really helped you guys out. Lastly, I hope you guys also go and visit the HashLips game. Like I mentioned, here it is. You can go to safelips.online and go and check it out. This is actually a smart contract that I've developed in a similar fashion to what I've shown you guys now, but I just want to show you what you can do as well. We're going to do a lot with this game by adding a lot of features, and stick around. Maybe I'll add to this tutorial as well. But thank you guys so much for watching this tutorial with me. You guys are great. Please remember to like and subscribe this video. It helps me out tremendously. And going forward, like I said, we're going to make similar videos to blockchain. We're going to do coding videos, and they're going to be a lot more concise and smaller. But it is necessary for me to go through this in depth, and I hope you guys really understood what I was talking about. If you have any questions, please don't hesitate to leave a comment, but also comment in the section below what was your favorite part. You'll find all the code in the comments in the description of this video as well. I just need to upload it everything to Github, which I'll do, and then publish the video. Have a nice evening, and I hope to see you guys in the next tutorial.